How to build intelligent agents with Python, a beginner's guide. In this video, you'll learn the essentials of creating autonomous agents using Python, equipping you with the skills to develop intelligent systems capable of decision-making. Welcome to our journey into the world of intelligent agents. Imagine systems that can make decisions autonomously, changing how we interact with technology. These agents are at the heart of automation, capable of learning from their environment, adapting, and performing tasks without human intervention. From virtual assistants to sophisticated industrial robots, intelligent agents are revolutionizing industries. In this video, you'll gain insights into creating these agents using Python, a versatile and accessible programming language. By mastering this skill, you'll open doors to exciting career opportunities in AI and beyond. Multi-agent systems, MAS, are collections of autonomous entities, or agents, that interact to solve complex tasks. These systems are designed based on agent-based modeling, a technique that simulates the actions and interactions of autonomous agents. The core idea is to understand how individual agents, each with their own goals and actions, can work together to achieve a broader objective. In MAS, agents must communicate, negotiate, and sometimes compete, making the study of these systems crucial for developing effective intelligent solutions. Understanding MAS is essential for creating scalable, efficient AI systems.
Before we dive into coding intelligent agents, it's crucial to set up a robust Python environment. Start by installing Python and an integrated development environment, IDE, like PyCharm or VS Code. These platforms offer powerful tools for writing and testing code. Next, configure essential libraries such as NumPy and SciPy, which provide the mathematical functions needed for complex computations. Setting up virtual environments will help manage dependencies and maintain clean project structures. Finally, ensure you have debugging tools ready to troubleshoot your code efficiently. With these setups, you're ready to start coding intelligent agents. Let's create our first intelligent agent using Python. We'll start by defining a basic agent class. This class will contain properties like name and state, and methods for actions the agent can perform. By encapsulating these details within a class, we create a blueprint for our agent, allowing for easy replication and modification. We'll implement simple functions such as move or decide, which dictate the agent's behavior. Understanding these fundamental concepts is critical as they form the basis of more advanced agent functionalities. Once implemented, testing ensures our agent behaves as expected in different scenarios.
In multi-agent systems, communication is key. Agents must exchange information to collaborate or compete effectively. We'll explore communication protocols that enable message passing between agents. Implementing these protocols involves defining the structure of messages and how agents interpret them. Coordination strategies like leader-follower or contract-net protocols help agents work together towards a common goal. Negotiation techniques allow agents to reach agreements in competitive scenarios. Testing these communication methods is crucial to ensure agents interact as intended, paving the way for complex, cooperative multi-agent systems. Decision-making is at the core of intelligent agent behavior. We'll implement algorithms that allow agents to make informed choices. Start with rule-based systems, where decisions are made based on predefined rules. For more sophisticated behavior, explore integrating machine learning techniques, enabling agents to learn from data and improve over time. Utility functions can be defined to help agents evaluate the desirability of different actions. Testing these decision-making processes ensures agents act in alignment with their goals, adapting to dynamic environments and making autonomous decisions.
Testing and debugging are vital components of developing intelligent agents. Thorough testing ensures that agents behave as expected in various scenarios. We'll implement unit tests to check individual functions and methods within our agent class. Utilizing debugging tools like breakpoints and step-through debugging helps identify issues and understand agent behavior. Common errors such as logic flaws or communication failures need careful attention. By rigorously testing and debugging, we ensure our agents are reliable and robust, capable of performing tasks autonomously with high accuracy. Intelligent agents are transforming industries by automating complex tasks and enhancing efficiency. In manufacturing, agents control robotic arms, optimizing production lines. In finance, they analyze market trends and execute trades autonomously. Healthcare benefits from agents managing patient data and assisting in diagnostics. Even in entertainment, agents create interactive experiences in video games. These real-world implementations showcase the versatility of intelligent agents across sectors. As technology advances, the potential for agents in various industries continues to grow, promising even more innovative solutions in the future. Congratulations on completing this journey into the world of intelligent agents. You've learned the fundamentals of multi-agent systems, how to create and test agents, and explored their applications in various industries. This foundational knowledge sets the stage for further exploration and specialization in AI and automation. We encourage you to dive deeper into advanced topics, experiment with different algorithms, and develop your own intelligent solutions. Share your thoughts and questions in the comments below, and let us know what topics you'd like to explore next. Your journey in AI has just begun, with endless possibilities ahead.